Hi class, today we're going to be covering changes of state. This is 3.7. There's two parts because there was a lot of slides. So I want to note that this tends to be one of the hardest chapters in chapter 3. So take your time, go over the work, do your reading, do as much as you can, and pay attention to the examples that are given to you to help you understand the content. Changes of state. So matter undergoes a change of state when it is converted from one state to another. So let's take a look at what we have here. So if we have water as a liquid, it's not in a fixed state or set of arrangements, but it is still attracted to each other. We have a solid, and a solid is a fixed arrangement that can only vibrate in action. And then we have a gaseous state, which molecules are separated with no regular, my mouse has got no regular arrangement. So when liquid water releases heat, it converts to a solid ice through freezing. So it has to lose energy in order for this to happen. When water absorbs heat, it converts into a gas through vaporization. So the more heat or energy it has, it will go into a vaporization state. When solid ice absorbs heat, it converts to a liquid. So it goes this way, which is melting. When ice absorbs, when solid ice absorbs heat, it converts to a liquid water through melting, or to a gas through sublimation, which bypasses the liquid phase completely. It goes from solid to a gas. When gas releases heat, so now we're at the gas portion, it converts to water through condensation. So it releases heat in order for this to happen. It releases energy. And when the gas goes to a solid ice through deposition. So it goes from a gas to a solid, that's deposition. Melting and freezing. When a solid absorbs heat, it changes to a liquid through melting. When a liquid releases back, it changes back to a solid through freezing, and these are reversible processes. So you need to make sure you understand. Melting is when it changes from a solid to a liquid. That's the melting point. And freezing, while it changes from a liquid to a solid. And water has a freezing point of 0 degrees Celsius, and it also has a melting point of 0 degrees Celsius. So both are at 0 degrees Celsius. You just need to know which way is it going. Is it going towards freezing, or is it going towards melting into a liquid? All right, so now we're at the heat of fusion. Heat of fusion is the amount of heat released when 1 gram of liquid freezes. And the heat of fusion is the amount of heat needed to melt 1 gram of solid at its melting point. So the heat of fusion is 80 calories per gram, or 334 joules per gram. Quantity of heat must be removed by 1 gram of water at its melting point. This will make more sense as we start doing a problem. These concepts are a little difficult to comprehend at first, so make sure you go over them. Heat of fusion, amount of heat released when 1 gram of liquid freezes, is the amount of heat needed to melt 1 gram of solid. So we have a heat. So you want to calculate the heat to melt water. So we need the heat that would be in joules, or it would be in calories. You would take the mass that we are interested in melting or freezing, and we would take the constant that we either need, 80 calories per gram or 334 joules per gram. And you see the grams will cancel out and it'll leave calories. For a given amount of substance, the heat released during a freezing has the same amount of heat that would be needed during a melting. So here we go. Heat of fusion for water. To melt water, so you see we have water as a solid, and so heat is added to the liquid. We need to add energy in order to break the bonds and to cause those vibration of the molecules to vibrate so much it breaks those bonds into a liquid and out of that fixed arrangement. So we take the water as a solid, we add 80 calories per gram, or 334 joules per gram, and that ends up producing water as a liquid. Still water, but now it's in a different state. To freeze water, we will remove that energy. So we'll take the liquid and we'll remove that energy from it, and it'll involve, heat is removed from the liquid, and it will produce a solid. So here's an example here. How many joules are needed to melt 32 grams of ice at 0 degrees Celsius. Now remember, 0 degrees Celsius is freezing and melting, but this is melting, and we want to know the joules. So we're given a certain amount of ice. We need to melt at 0 degrees Celsius, and we're going to use the heat of fusion constant. So if in the beginning, it's best to write a plan of what you need to do, the steps. So we have the grams, we need a conversion, and that should cancel out the mass and only leave us with the joules. So we take the constant that we know. In this case, we're using joules. So we're going to write 1 gram of water equals 334 joules, and we'll set that up as an equality, and we'll end up solving the problem. So 32 grams of water, 32 grams of solid water and ice, make it easier, 32 grams of ice, and we use the conversion of 1 gram of ice as a solid. Make sure you have the physical state of S here, that's for solid, cancels out, and we put the 334 joules on top. That's 3 sig figs, and the 1 gram is exact, so we're not interested in that. And it ends up producing 10,700 joules. We would either write this in scientific notation, or we can leave it like this. And remember, the trailing zeros don't matter, so it's 3 sig figs. Sublimation and deposition. So when a solid absorbs heat, so we have a solid, when it absorbs heat, it changes to a gas through sublimation. It bypasses the liquid phase. When the gas releases heat, it changes to a solid through deposition. So again, bypasses the liquid state, just goes from one phase to another and not involving all three. So when the sublimation occurs, the particles on the surface of the solid change directly to gas. There is no temperature change. So when this is happening, there's no temperature change. All the energy is going straight into the change of state or phase, not in increasing the temperature. When these changes happen, there's only two things that can happen. Either the temperature will go up and there's no change of phase, or there's no temperature change and all the energy goes into changing the phase. But it cannot do both at the same time. When deposition occurs, gas particles change directly to a solid. And like the other one, this one is also reversible. So sublimation. Sublimation is a solid to a gas. Dry ice is a perfect example that it undergoes sublimation, which is a gas. So it's a solid below negative 78 degrees Celsius. But once it hits negative 78 degrees Celsius, it will go into a gas. So when you bring this out into the environment, it will immediately go into a gas because our temperatures are well past negative 78 degrees Celsius. Sublimation is solid to a gas by passing the liquid phase. Sublimation is used to prepare freeze-dried foods for long-term storage. Water vapor will change to a solid on contact with the cold surface. And excuse me, so these are just, make sure you understand sublimation is a solid to a gas, no liquid phase. All right, so we go to evaporation. When a liquid absorbs heat, it changes to a gas through vaporization. When the gas releases heat, it changes to a liquid through condensation. So it condenses. So let's take a look at these. Evaporation, we should all know, because if you've tried to ever boil water, if you leave it long enough, it will evaporate away. The molecules of water at the surface will leave the water and go into a gas form. Condensation is when the water molecules lose energy and form a liquid. So they go back from being a gas into a liquid form. During evaporation, molecules of the liquid are converted to gas at the surface of the liquid. When water is boiling, all the water molecules acquire enough energy to leave in the form of a gas. Bubbles of water vapor appear through the liquid. During boiling, molecules of the liquid are converted to gas through the liquid as well as the surface. So evaporation and boiling. Evaporation doesn't have bubbles that will occur. See, bubbles cannot form. Boiling will have bubbles. You will see bubbles form, and that is the water molecules leaving. Heat of vaporization. The heat of vaporization is the amount of heat absorbed to change 1 gram of liquid to a gas at the boiling point. The heat of vaporization for boiling at 100 degrees Celsius is heat absorbed when 1 gram of water changes to steam. So this is when we're going from a liquid to a steam. And it's quite bigger numbers than what we dealt with. So going from ice to a liquid or liquid to ice, the numbers were a lot smaller than what we have here. We have, if you look at here, we have liquid water, and we add excuse me, we add energy of 540 cals per gram, or 2260 joules per gram, and it produces gas. So enough energy goes in to create the gas form. The heat of condensation of water is the heat released. So in order for this to happen, we have to now remove that extra heat that allowed this to go into vapor, and we use it the other way, where we are now removing the heat, and that causes it to go back into a liquid. How many kilojoules are released when 50 grams of steam from a volcano condenses at 100 degrees Celsius? So we have to pull out the information we know. We have 50 grams of steam at 100 degrees Celsius. Kilojoules released when steam condenses at 100 degrees Celsius. That's what we're looking for as an answer. And we need to know the heat of condensation, and we'll have 2260 joules per gram. So let's take a look at what we have. We need to make out some kind of map or plan to determine what we need to do. So we're going to start out with grams. We're going to have the heat of condensation. Then we're going to end up with joules, because the mass will cancel out with this conversion. Then we're going to need a metric conversion, because this is asked for in kilojoules. And that will produce our answer if kilojoules needed. So let's pull out our conversions. We have 1 gram of water that goes from gas to a liquid. So it's condensing the steam back into a liquid form. And that is 2260. So this is 1 gram of water, and the energy needed is 2260 joules, 2260 joules. Then we need the conversion for the metric of joules to kilojoules, and know how to set them up and which one we're going to use. So here we're going to do 2 steps. We're going to take the original mass that was given to us, and we're going to use the conversion of the heat of condensation. So we set up grams at the bottom. We use the joules on top. That cancels out the grams. Now we're at joules, and now we need to change this to kilojoules. So we use the metric conversion, and our answer is 3 sig figs, and it's 113 kilojoules released. So how many kilojoules are released when 50 grams of steam from a volcano condenses, goes into liquid form at 100 degrees Celsius? It is 113 kilojoules released for 50 grams of steam. And that's it. Next lecture, we're going to be looking at heating and cooling curves, and all of this is going to be tied together in the end of that lecture.